My name is Maxim Zakharenkov. I'm from Riga and from Latvia, and I'm Java developer/architect and work for company RevJet. And more information, if interested, you can find on the Topconf agenda. But today I will speak about SQL and NoSQL world, and I will compare two SQL and NoSQL databases, MySQL and Cassandra. I had a chance to work with both of them, first with MySQL, and afterwards I discovered something interesting and some interesting differences between them. And I'm going to compare just exact two databases, concrete databases, not just something SQL or NoSQL, because there is a lot of different databases and I don't know all of them. MySQL is number 2 database, relational database in the world. It's open source and it's about 20 years old, pretty mature, well defined. Cassandra is number 2 NoSQL database in the world, and it's about 7 years old, and it is pretty mature for NoSQL world, and more rankings you can find in the link below. And to illustrate my comparison cases, I will use very simple data model. Imagine we are going to build a website where users can log in, register themselves, and post some comments. We have two very simple tables with one-to-many relationship, and so it should be pretty clear to developers what's going on there. So comments have creation date and user ID back reference. And in MySQL, it will be pretty similar schema, just we add here also primary key, and it is auto-incremented field. It's a feature supported by MySQL, where you can define a kind of sequence which monotonously is growing as soon as you insert some new user records. Same thing with comments. We have primary key and it's auto-incremented. And also we define two indexes on creation date and on user ID, because we are going to search using these fields. And technically, MySQL uses B-tree data structure for storing and handling its data to make these algorithms more effective. I think it should be pretty familiar for developers. The nodes can contain primary key value references, and it's easy to go down from the top to the leaf node and find where our data is located. And in this B-tree, data is located in leaf nodes only. And this way, MySQL handles its data. In case of index, MySQL uses pretty similar B-tree, but instead of data elements in the leaf nodes, it stores primary keys. So it means that if we are going to search by user ID here, we have user ID as indexed field. We find all necessary comments which are identifiable by this user ID and find their identifiers. And then MySQL has to do similar lookup in the primary key tree and find the exact data. So two lookups are necessary for doing some search operation here. In case of Cassandra, everything is somehow different. Cassandra's approach is to use one table for storing this data. So in this case, we have users and comment table. And in one record of this table, we store user information and all comments which were posted by this user. And name and surname fields are marked here as static fields. It means that they have one-to-one relationship to our primary key. But comment ID is so-called clustered key, and it's a key inside our Cassandra record. But record in Cassandra is not called record, but it's called partition. And it's a key inside one partition, and it identifies our separate comments the user has made. And additionally, you should pay attention that we don't use some kind of auto-incremented fields. Here we use time UID keys, which are globally unique identifiers, and they can be generated at any client machine, and they are guaranteed to be unique, and we don't have to use any central storage of current key values. On one hand it's good, on one hand it's bad, because time UID takes much larger space for storing, and physically the partitions could look somehow like this, as I shown. These two slides are somehow matched to each other, and user ID has pretty long number or key, which is this globally unique identifier, and it's one-to-one with name and surname, and we have multiple comments. So here are two partitions. One partition is with 3 comments, another partition with 2 comments. So I think there is nothing to explain here more. Just one thing you should know is that in Cassandra, partition is always stored completely in one node. It can't be that one partition is split to multiple nodes, and it's important. So let's consider case number 1. We are going to show all comments our user ever posted. He logs into his page, and in MySQL the query would be pretty simple. We have a join between users and comments table, and we have filtering criteria by our user ID, and the complexity of this query would be somehow defined like it's shown here. First we find comments by user ID index, and it's some kind of logarithmic time multiplied by some number of comments. And another lookup we have to do, we just have to look up into users table and find name and surname information. In case of Cassandra, we have pretty similar query, but it's not SQL, it's CQL, stands for Cassandra Query Language. It's very similar to SQL, but with some peculiarities. It's not one-to-one, because Cassandra has own limitations, MySQL has own. And in this case, we are querying only by primary key, and our data comes from one partition, and in most cases it's just constant time for searching the data. I won't go into deep details about worst cases. Maybe if you come, I can explain later. If we take case 2, which is a bit more complicated, we are going to display all comments which were posted today or at a certain date. In this case, our query will be modified so that we filter by creation date. And pretty similar thing, we can estimate our complexity here. First, we find multiple comments, and afterwards we find data for multiple users. And in contrast with previous example, we will have to do multiple lookups to users table. And the query is more complicated, but MySQL can successfully manage that, and no problem, just it takes more time. In case of Cassandra, actually we can't do this query with our existing data model, because in Cassandra we cannot make joins. We cannot make another table and join and make join like this. And our existing table is indexed only by user ID key, and we cannot allow ourselves to scan the table fully, since we have a lot of data and just it's useless to do that. But Chuck Norris considers that real man doesn't need any joins at all. And indeed, Cassandra's way to solve this issue is to introduce another special table, is to introduce data denormalization. And it's a special table which addresses our case number 2. We create a table where we have primary key day value. It's a kind of number of current day. It can be a day of the year or day of the century, I don't know. But primary key. And in one partition for this day, we store full comment information with user identifier name and ID. And we can easily query these partitions, and we can meet the requirement, and it can be pretty fast. On the other hand, we have price for that. We have to pay because in our application now we have to update both of the tables. Yeah, it's additional coding complexity you should be aware of. And to summarize the case number 2, so no additional code changes are required for MySQL, just modifying a SQL query is enough. And in MySQL we don't have data duplicates, but in Cassandra we just query one partition, and the query will be pretty fast. I'm sorry, just could you please ask your question later, because there is more amount of time. Case number 3. We are going to extend our data model, and we are going to add a gender field to our user information. And in case of MySQL, it is pretty heavyweight operation. If we have a lot of data in our table, you have basically MySQL, when you change your schema, creates another table. It copies all the records to this new table, performs all the reindexing stuff, because it has a certain amount of disk space to be reserved for each record, and it should be reserved for this concrete field. And in some systems, I know it may take several hours or several days even, and your server will be heavily loaded by this time also. In case of Cassandra, we have partitions And in partitions, we are not limited to the number of columns we can add. And this alter table statement works almost immediately. And actually, that's the reason why Cassandra is so called wide row database. Yeah, and let's take a look at a bit deeper under the hood how Cassandra works. So we have insert, update, or delete operations from our application. And initially, the data is written to memtable. Data is also written to some commit logs, but I won't talk about them. They are also very fast, just append-only operation to separate disk. But first, data comes to memtable. It has some size limit, let's say 64 megabytes. And as soon as this memtable is filled in, it's converted to SS table, which stands for sorted string table. It is a disk file, and all elements inside this sorted string table are ordered by our partition key. So searches inside this SS table happen in logarithmic time. And eventually, when we fill in data into our Cassandra, we have a lot of SS tables. So first table, second table, and so on. And it might be that first we have written some data into table 1 for one partition, and in table 50 we overridden data for the same partition, and a read operation selects data only which was with the latest timestamp. So it's a task for the read operation, but you will probably ask that it's a big job to scan all of the SS tables to find the exact data which is stored for requested partition. Yes, that's true, but for that, Cassandra has special kind of data structure called Bloom filter. It's in-memory, very efficient like index, which is attached to all of the SS tables, and using this index you can easily filter out those tables which do not contain these requested partitions. And normally in practice you get either one SS table or like 4 to 5 tables. It's somehow tunable, depends on the amount of memory you have for Bloom filters. And then read operation can very effectively look up and extract necessary data. And also it worth to mention that deletion operation is also write operation. We perform writing of a special deletion marker called tombstone, and it marks that our previously written data is not valid anymore, and read operation also understands that, and it shows us that there is no data here anymore. And there is one problem with that, because you may have data for one partition which is old and which is new, and it occupies disk space. And to address that, Cassandra has a compaction manager background process which does all the necessary garbage collection, and it merges multiple SS tables together and produces clean SS table copies, but it takes some time to compaction manager to do it. It may take even several days that your obsolete data is stored, still stored on the disk, and you should know that you have to have some reserve on the disk space when you use Cassandra. So, case number 4. So as we've seen our architectures, in case of MySQL, if we consider write performance, we are doing insert, update, or delete operation, and first MySQL needs to find the data record where it is located in the tree, and afterwards it performs some updating stuff of this data. In contrast, in Cassandra, as we have seen, it doesn't perform any lookups for our previously written data. If it exists or not, Cassandra doesn't care about that. Just it performs very simple append-only writes. And that's why Cassandra is very fast in performing write operations. It can just take extreme amount of data, almost as disk speed allows you. In case of MySQL, if you have a very big batch of data you have to insert, and it's unordered, it's a big job for MySQL to find the locations, to insert, and sometimes even rebalance the B tree. So the performance will be much less. But on the other hand, MySQL keeps your data storage always compact, and you don't waste your disk space. Transactions. So in case of transactions, for sure MySQL, and we are talking now only about one node, MySQL definitely beats Cassandra because MySQL is fully ACID compliant. On the other hand, Cassandra cannot completely fulfill ACID requirements, and mostly Cassandra works well with one record updates, and one record updates basically work well with transactions. I won't go deeper into the details, just it's so-called eventually consistent. And if you consider to use Cassandra, you should carefully study this topic, what Cassandra can do, what Cassandra cannot, because if you have a banking application, you definitely will need some very robust transaction support. If you have some website like our case, you can allow a certain degree of freedom here, and it's not required that always a new user which wants to read comments will get some 100% consistent state. It's enough to get a bit obsolete data, and it's not a big problem. And actually that's a point a lot of web applications, high-load web application, play on. Yeah, they just reduce their consistency a bit, but they get higher performance and some other fancy stuff from Cassandra. Next case, horizontal scalability. In terms of horizontal scalability, what it is actually? It's a possibility of the system, of the database, to manage multiple nodes. So it's not enough with one server, and you want to increase your capacity, you want to put more servers, and you expect your capacity to increase. And in case of MySQL, it was not actually initially designed for horizontal scalability. Initially, it was designed as a simple database, and there are no out-of-the-box tools in MySQL so that you can add more instances. And you have to invent a kind of sharding mechanism which do some data partitioning among multiple servers. And either you create your own client library for that or use some third-party libraries. So you have to have a kind of expertise in this domain. Also, in case of this horizontal scalability, you won't be able to use classical joins anymore because potentially your data is spread among multiple nodes, and you have to have a kind of mechanism of multi-query from multiple nodes and then aggregate that somehow on your client side. So it's not that easy. And same thing with auto-incremented keys. So you have multiple nodes, one node can die at some point of time, and your auto-incrementing mechanism is not centralized anymore, and you have to think how to overcome this. It's possible. There are highly loaded systems which do successfully that, but people should have enough expertise there. In case of Cassandra, it was initially designed for high scalability, and as soon as you add more nodes, you get your capacity growing linearly. Twice more nodes, twice more capacity. And Cassandra has a lot of officially supported client libraries for Java, PHP, Ruby, and so on, and they automatically can understand addition of new nodes into your cluster, and they automatically will go to the right server for the right data. And as we have seen, also Cassandra simulates usage of the right design patterns for high scalability. So we don't use joins there because of this aggregation complexity. So mostly Cassandra encourages you to store most of the data inside one partition so that you can look up into only one server and get your necessary data. Yeah, it's a trade-off, but it solves this horizontal scalability problem very well. Fault tolerance. Same thing. Actually, MySQL has some support for fault tolerance, but it's not as complete, because in most cases you will get MySQL with a single point of failure. You can set up your master-slave replication in MySQL where slave tries to keep a data replica of your master, but as soon as your master dies, so it's normally some kind of problem. You have to do something with the slave, either promote to master or do some other tricks. Different solutions were tried, but in a lot of cases people just use manual system fault tolerance. They keep this master-slave infrastructure, but as soon as something dies, they fix it manually, put new server, and only then your system becomes fully functioning again. In case of Cassandra, there is no single point of failure, and all of the servers are equal, and even more, Cassandra supports replication factor, so that you can guarantee that when your data is written, it is replicated among, for instance, 3 servers, 3 nodes, and as soon as one node dies, just nothing happens for client application. It will go for a live node, and it will get necessary data, and by this time your ops people can restore the dead instance and return back to the cluster. Everything is very simple. And also Cassandra supports such fancy stuff as multiple data center support. You can just keep your data completely in different data centers and complete replicas, and even if one data center dies, so you can switch to another one. There are also some more features for fault tolerance in Cassandra, but I think you should explore them yourself. Just it increases this fault tolerance level. Yeah, and to summarize our cases, so here I created a kind of table which may help you in deciding what to use, what to choose. So what is stronger in MySQL side and what is stronger on Cassandra side. It's not just universal recipe, it's a kind of helper. You definitely have to learn deeper about that, but it can be a kind of a starting point of which topic to pay attention to. And definitely you also have to do some benchmarkings and analyze your data models. It also depends on your existing expertise in MySQL and Cassandra, because I can't recommend either one or another. I respect both, and they are both pretty mature, and sometimes it's really a matter of your expertise and what are you going to do more. So some manual stuff with MySQL when something dies, or just try to operate with some automated cluster. Yeah, but I think it can be useful, and you could try yourself. And at this point I want to end my presentation, and it's time for your questions. And yeah, thanks for coming. Yeah, you had probably. Okay, it's answered already. Okay, yeah, that's good. Some more questions? Yeah. Excuse me, could you please speak up a bit?
How are write operations handled if I have multiple partitions which have the same field? Like, for example, you have the users components and data comments.
Yeah.
So I have a client who wants to update comments.
Yeah.
And comment is included in multiple partitions. What happens?
So in one table, as we defined in our data model, one comment in one table. One comment will be only in one partition. Yeah. So in this case, you will have to update two tables, and one partition will be in one table for which is indexed by day, and another will be in the users table, which is indexed by user ID. And so you will have to update only two partitions in this case. So just you do two operations separate, and so it won't be transactional for two records. So one transaction, another transaction. Yeah, two transactions here. Yeah, some more questions? Yeah, don't be shy, just use your time. Okay, yeah, then I'm done, and thanks again for coming.